Have you ever wondered about Titan, Saturn's largest moon, and its mysterious methane lakes? Our journey begins in the year 1655 when the Dutch astronomer Christian Huygens first pointed his newly invented telescope towards the heavens. Through the lens, he spotted a speck of light orbiting Saturn, a world that would later be known as Titan. This marked the birth of a new era in the exploration of our solar system, opening up a realm of possibilities that would captivate the minds of scientists and space enthusiasts for centuries to come. Titan, as we would later discover, is no ordinary moon. It's the second largest moon in our solar system, surpassed only by Jupiter's Ganymede. But its size isn't what makes it so intriguing. It's the tantalizing mysteries that lie beneath its thick, orange-hued atmosphere that truly sets it apart. In the early years following its discovery, astronomers could only speculate about the conditions on Titan. Its dense, cloudy atmosphere made it almost impossible to see the surface. Yet certain observations hinted at a world unlike any other. The moon seemed to have an atmosphere, something that was unheard of for a moon at that time. This stirred the curiosity of scientists, leading to a series of hypotheses and assumptions about the moon's atmospheric composition. Some even suggested the presence of methane, a gas associated with life as we know it on Earth. Over time, our understanding of Titan evolved, thanks to the advancements in technology and a series of space missions aimed at studying this enigmatic world. What was once a mere speck of light in Huygens' telescope transformed into a world full of potential, inviting us to delve deeper into its mysteries. The intrigue surrounding Titan's atmosphere and the possible existence of methane lakes set the stage for some of the most ambitious space missions in history. It wasn't just a curious object in the sky anymore, but a world that promised to redefine our understanding of life in the universe. The mystery of Titan was just beginning to unfold, piquing the interest of astronomers and space enthusiasts alike. Our understanding of Titan took a giant leap forward with the Voyager missions of the late 20th century. Imagine the year is 1977. The Voyager missions, two unmanned spacecraft aptly named Voyager 1 and Voyager 2, are launched by NASA with the audacious goal of exploring the outer solar system. As they journey through the cosmos, these robotic explorers are tasked with studying Jupiter, Saturn, Uranus, Neptune, and their respective moons. Titan, the largest moon of Saturn and the second largest moon in our solar system, was a prime target for these missions. However, Voyager 1's encounter with Titan in November of 1980 didn't quite go as planned. As it turns out, Titan was cloaked in a thick, opaque atmosphere, unlike anything we had seen before. This dense, smoggy haze made it impossible for Voyager 1 to observe Titan's surface directly, thwarting the mission's original goal. Yet this setback didn't dampen our spirits. Instead, it stoked the fires of scientific curiosity. The Voyager missions revealed that Titan's atmosphere was primarily composed of nitrogen, with traces of methane and other hydrocarbons. This unique composition suggested that Titan might harbor an active weather system, possibly even rain and lakes, but of methane and ethane, not water. Voyager 2, while not getting as close to Titan as its predecessor, provided valuable data about Saturn and its other moons. It confirmed and expanded upon Voyager 1's findings, further cementing the idea that Titan was a world unlike any other in our solar system. So even though we couldn't see Titan's surface, these missions were anything but a failure. They laid the groundwork for future explorations and sparked a new wave of interest in Titan. We began to understand that if we wanted to learn more about this mysterious moon, we would need to devise new strategies and technologies capable of peering through its hazy veil. Despite the challenges, the Voyager missions only increased our curiosity about Titan and its enigmatic surface. In 2005, the Huygens probe, part of the Cassini-Huygens mission, finally pierced Titan's veil. This was no ordinary journey. The probe, named after the 17th century Dutch astronomer Christian Huygens, took a 7-year voyage through the cosmos before it reached its destination. But the real adventure started when it began its descent onto the surface of Titan, Saturn's largest moon. As Huygens plummeted through the atmosphere, it began to collect data, acting as a high-tech weather vane. It measured the temperature, pressure, and density of the atmosphere, giving us our first real glimpse into the conditions on this distant moon. But the most significant discovery was waiting on the surface. Huygens sent back images of a landscape eerily similar to our own, with mountains, valleys, and most notably lakes. But these weren't lakes as we know them. They were filled with liquid methane and ethane, substances that on Earth are found as gases. These were the first stable bodies of surface liquid found off our home planet. This discovery had profound implications. For one, it suggested that Titan has a weather system similar to Earth's, with methane playing the role of water. Just as water evaporates from Earth's oceans, forms clouds and falls as rain, so too does methane on Titan. This finding sparked curiosity about whether Titan might harbor life, albeit life as we don't know it. The data from Huygens also hinted at a dynamic geological history. The presence of river valleys suggested that Titan's surface has been shaped by flowing liquid, much like Earth. And the discovery of an ice volcano hinted at internal heat sources, pointing to a surprisingly active world. The Huygens probe opened a new chapter in our understanding of Titan, revealing a world both familiar and utterly alien. This mission gave us a tantalizing peek at a world where the rules are rewritten, and where what we thought we knew about planets and moons is turned on its head. It sets the stage for future explorations, and the potential for astonishing discoveries yet to come. A world where rivers and lakes are not made of water, but of methane and ethane. Welcome to Titan. Imagine this, if you will, a landscape dominated by bodies of liquid so different from our earthly conception of lakes and rivers. These are not bodies of water, but rather bodies of methane and ethane, chemicals typically found in gas form on Earth. These methane lakes of Titan are not just mere curious features. They are key elements in a weather system that is eerily similar to Earth's. Just like how water evaporates from our oceans to form clouds and rain, methane on Titan evaporates from its lakes into the atmosphere, condenses into clouds and falls back as methane rain, replenishing the lakes. It's a methane cycle that mirrors Earth's water cycle. Now you might be wondering, how do these lakes form? Well, it's not entirely clear, but scientists believe that they are likely the result of a process similar to sinkhole formation on Earth. As liquid methane and ethane rain down on the surface, they might dissolve the ground to form depressions that become lakes. The largest of these lakes, known as Kraken Mare, is larger than the Caspian Sea on Earth, spanning an area of over 400,000 square kilometers. But unlike our seas, Kraken Mare is filled with methane and ethane, and its surface temperature is a chilling -180 degrees Celsius. It's a place so alien yet so familiar in its dynamics. But here's the most tantalizing part. These methane lakes might hold the potential for life. Not life as we know it, based on water, but methane-based life that could survive in Titan's extreme cold. While we have no evidence of such life yet, the possibility is fascinating, pushing the boundaries of our understanding of where life can exist. In this frigid world of methane lakes, could there be the potential for life as we don't know it? It's a question that continues to inspire scientists and space enthusiasts alike, driving our curiosity and our exploration of this captivating moon of Saturn. With so much yet to discover, what does the future hold for the exploration of Titan? As we peer into the future, we find a horizon dotted with upcoming missions, each holding the promise of new discoveries and breakthroughs. Among these, one mission stands out for its audacity and ambition: NASA's Dragonfly mission. Set to launch in the late 2020s, Dragonfly is no ordinary spacecraft. It's a dual quadcopter designed to fly through the dense atmosphere of Titan, leapfrogging from one intriguing site to another. It's like nothing we've ever sent to another world before. This mission aims to explore diverse environments, from organic dunes to the floor of an impact crater, where liquid water and complex organic materials key to life once existed. But Dragonfly isn't just about answering the big questions about life on Titan. It's also a stepping stone, a way for us to understand how to operate in environments that are incredibly different from our own. And this understanding may just pave the way for the ultimate goal: human exploration of Titan. Now let's be clear, we're not packing our bags just yet. The conditions on Titan are harsh, to say the least. Its surface temperature hovers around -290 degrees Fahrenheit, and its atmosphere is mostly nitrogen, much like Earth, but with a significant amount of methane. But Titan also has a lot going for it. It has a dense atmosphere that could shield explorers from cosmic radiation, and its low gravity would make moving around much easier. Sending humans to Titan is a dream, It's a dream that pushes the boundaries of what we think is possible. It challenges us to develop new technologies, to solve problems we've never faced before. And who knows, maybe one day in the not-too-distant future, a human footprint will join the tire tracks of the Huygens probe and the landing marks of Dragonfly on the surface of Titan. As we continue to explore Titan, who knows what mysteries we may uncover next?